Hello friends, my name is Shiban and I'm the co-founder of a startup called Klotho, which enables writing universal backend applications that run anywhere. I led teams in the Visual Studio org at Microsoft in the developer division, and more recently led the cloud services org at Riot Games. My co-founder Aaron led teams in Linden Lab, Los Alamos National Laboratory, and at Riot Games. Small teams need to move fast, focusing on building products, but products also need backends, and at a certain degree of scale or product complexity, teams need to use the public cloud, whether it's AWS or GCP, Azure, or even something more specialized like Cloudflare. The mechanics of building a backend system is not simple, and the complexity grows as the application requirements grow. A real application uses databases, caches, multiple application services with non-trivial topologies, while still needing to satisfy latency, throughput, reliability, scalability requirements, and be auditable and secure. Research and surveys show that the biggest unexpected factor in the slowdown of teams is underestimating the complexity that microservices introduces to developers and cloud engineers. I'd like to introduce you to Klotho. Klotho is a new open source tool that can transform plain applications into cloud-native ones, using a few declarative and contextual annotations that give your code cloud powers. It makes it possible to automatically generate Pulumi code for the necessary components and resources that are needed to power your application in a cloud setting. It then surgically modifies your application code to wire in the usage of those cloud resources. For example, this is a Python application that uses Fast API and a Redis SDK, and just by adding the persist capability and the expose capability, Klotho can transform this application into a cloud architecture, which in this case has an API gateway, a Lambda, and an Elastic Cache, wired with VPCs, IAM policies, and the needed configurations to have the Lambda talk to it. This approach is part of a larger paradigm called infrastructure from code. So what is infrastructure from code? It is a broad term that refers to tools which are able to analyze and infer the cloud resources needed for an application to run from the application code, and then creates and maintains those resources using a description language. But how is it different than infrastructure as code? Infrastructure as code refers to tools that allow developers and cloud engineers to describe infrastructure. You write templates or code that describes Lambdas or Kubernetes clusters, IAM policies, SQSs, gateways, and how it all wires up together, while the application code is external to that and is loosely aligned with that infrastructure by injecting connection strings or environment variables into the application. So how does this relate to Pulumi, and how does Klotho help? Klotho frees developers, especially in earlier stages, from having the deep expertise in infrastructure engineering. It allows them to zoom out and think about the features and capabilities they're building, while letting Klotho leverage its understanding of architectures to power those applications through using a few annotations. But the key here is that once the complexity gets to the point where you do need to dig deeper into the infrastructure as code or the Pulumi code, you can. And you can learn about how these things are wired up just by observing the code that Klotho generates. And so it serves both as an understanding layer for you to be able to observe what Klotho is doing, but also for you to be able to patch it, change it, and also attach it to your existing Pulumi code to expand it beyond what Klotho knows how to use today. And it maintains the power of everything that Pulumi brings to the table, from stack management to the deployment process, configuration storage, with Klotho absorbing the complexity of building those and translating those application constructs into cloud constructs. To show you how this works, I'm going to ask Aaron, my co-founder, to walk you through a demo.
Next, I'll be giving a demo to showcase some of Klotho's capabilities. So for this demo, we'll be starting with a plain application. This is a TypeScript app. And the main thing to show here is that there is no extra dependencies, SDKs, or anything that we're dependent on. This is a native app that will run locally. So what this app will do is it will take an image, in this case, an image with a gradient, and will extract the text using OCR and return a JSON payload, which has the original base URL and the extracted text as a string. So to showcase that, here's our app. Just again, local app. It's exactly the same as what I showed on the slide. and I am going to go ahead and run TS Node against our source index file, which will start a little web server listening on port 3000. And what I will do is I will curl passing in the same exact image that we have hosted on our service. And I'm passing the result to JQ just to kind of show it nice and formatted. And what you see is you get back the expected result. Right now, it's all done in one shot, but we have a separate endpoint that will also return the result. In this case, pulling it from a local ES6 map, which is storing the temporary result as well. So if we hit this multiple times, you should continue to get the same results back. So now that we have this local app, what we want to do is use Klotho to create a cloud native version of that app. So let's start with the most basic version of that, which is a app hosted in some sort of compute in the cloud being pointed to by a public accessible gateway, API gateway in this case. So in our architecture, that'll be an API gateway connected to a Lambda function, which will host our entire application. So to accomplish that with Klotho, we will be using our annotation system, which allows us to annotate parts of the code, and that will then turn it into a cloud-native version when it's compiled and deployed. So in this case, what we're going to annotate is our app.listen, which is the part of the app that's listening on port 3000 for requests. We'll be using the Klotho expose annotation, which takes two parameters, the target, which can be public or private. We're specifying public for now because we want this to be a publicly accessible endpoint, and a name or an ID. And this has to be a unique identifier for your app. In our case, we will call this, we'll go with the same name, OCR Gateway. So what I'm going to do is I will then take this app. We'll be running two commands next against this app. The first is TSC, which will take our TypeScript app and compile it into a JavaScript app. And the second is the Klotho compiler, which will take the compiled output and two pieces of metadata, the app name, which we're calling Pulumi demo, and the provider, which is AWS in this case. And when we run this, the first one should create a dist directory, and the second one will create a compiled directory based on what Klotho found in the application. And you can see that it's detecting certain things here, including the routes as part of the Express app that we're annotating. And that will generate a compiled directory, which has everything you need to deploy, run, and operate your service. So this has the Pulumi IAC, along with a very useful diagram, which I will pull to the side here, which is the architecture that we've generated so far. So as you can see right now, this matches our expected architecture. I also want to take a minute to pull open the Pulumi code just to give you an idea of what's happening in here. So in this case, it's TypeScript code, and this TypeScript code is everything that Klotho uses or that Pulumi will then use to deploy this app. So this is dynamically created based on your application. We only pull in the pieces that you need. And it's all the components, including IAM policies, security groups, everything you would need for this app to run and operate inside of AWS. And just to show that that is the case, I'm going to do a quick PulumiUP just to give you a preview of what this will look like. Right, so to start, I'll go into this compiled directory. Okay, so just to show how this would look, I'm going to run a PulumiUP against our generated stack. And you see that this generated all of the components we care about. So it includes ECR repository for holding our container images, IAM roles, the gateway itself, along with CloudWatch monitoring, et cetera. If you were to completely deploy this, you would end up with a public endpoint at the very end, which you can curl with the exact same arguments that we've used inside of our local app, and it'll work in the cloud version as well. So this is a very basic app, but we can expand this functionality very easily with Klotho. So the next thing we would like to do is make our data be persistent across sessions. So right now, I mentioned before that we're keeping statuses inside of an ES6 map. What that means is that this is all in memory, which if the process were to die or you were to have a cold start of your Lambda, that means the map would clear and you would no longer have any of the statuses that you had stored previously. So the first thing we would like to do is modify this to allow us to persist that data between sessions and across Lambdas. So what I will be using here is the persist annotation, which will take our plain ES6 map and turn it into a DynamoDB table. We'll call this same as before, text result. And now I'm not changing the code in either way. We're still just reading and writing from this map, but now it will, behind the scenes, turn that into DynamoDB calls. So if we run the same TSC and Klotho compile step as before, and we have the same image pulled up on the side. With our new annotation in place, what you'll see is that it will pick up that text result, and now we have DynamoDB added to our architecture. Similarly, if I were to do the same Pulumi deploy, you would now see that there's all the bits needed for that DynamoDB to exist, including IAM roles and everything else it means. So next, let's talk about a situation where your app functionality needs to change and you need to make your app handle things asynchronously. In this case, the reason for doing that is because OCR might be compute heavy, and you might want to run that in a separate unit of compute rather than the APIs, or split it into a separate Lambda. So what we'd like to do is turn our architecture into this. We'd like to have a write path where you write on to this OCR API. It then does the processing and stores the result in text result. And similarly, the read path goes through API here, and you can then read those results. So the way we accomplish that in Klotho is by using the exec unit annotation. So I will go to each of our routers. And like I mentioned, we want to make the routers be their own area of compute. So I'll make one here called API. I'll make one over here on the OCR route file called OCR API. And lastly, for the piece of TypeScript that's actually doing the recognized text, which is the OCR operation, we'll make that its own as well. And we'll just call this, we'll call it OCR process. And once again, recompiling, the end result after all of that is what we would expect. Now we have 3 Lambdas connected together. One thing to note here is before these were calling each other with function calls, and we obviously didn't change that piece of code. So what's happening now for this to be able to invoke this other Lambda? The answer is we take those calls, which are originally function calls, and we translate them into RPC calls. So now this is a remote procedure call. When you call it, it's actually sending a request across the wire and getting the result. Things to note here, nothing in this is concrete or set in stone, meaning that you can do things like through configuration change the network protocol being used. Right now it's REST. It could be gRPC as well. All that will be handled automatically and will change just on next compilation with config changes. We have this write path and this read path. Right now, it seems kind of weird that we have these 2 Lambdas on the write path, like it could have just been one. The reason for that is because we really want to make this app be event-driven, meaning that we want to decouple the request to recognize the image to reading what the result is, especially if people were to enqueue a bunch. So the idea here now is when you send your request to write, we enqueue that into an event, and the OCR exec has a handler for that event, which takes the event and does the processing. So the way we accomplish this with Klotho is we'll begin with a emitter, which is a ES6 emitter. Nothing special here. This is all handled in memory. And emitters allow us to specify handlers and also to emit events. So in our case, our router is going to be emitting an event. So rather than just doing recognized text and returning the result, instead what we're going to do is pull this emitter in and have it emit a recognized event and pass in the URL. And then we change our results to, instead of being the plain result, just say we're recognizing text. So now when you do a post, you should get back this recognizing text. And then when you do the subsequent read, assuming it's finished, you'll get the result. Similarly, let's go ahead and save this. We'll go to our OCR module, which is the place where we want to put our handler. And we're going to add a handler for recognized events using the same emitter. I'm adding an import here. And so what happens is when we receive a recognized event with the URL, we call our recognize function, and that result is then stored inside of DynamoDB. And lastly, this won't work in a world where you were deployed this to cloud because we have 3 separate Lambdas. I mentioned an emitters all in memory, so they couldn't pass events between each other automatically today. But we're going to accomplish that by using the Klotho PubSub capability, which takes this emitter and turns it into an SNS queue, which lets us persist these events in the cloud. And we'll call this OCR PubSub. Once again, let's recompile. And as expected, we now have this SNS PubSub in between our OCR API and our OCR process. So to showcase the final capabilities of the app, I'm going to deploy this version to the cloud, and we're going to curl the public API gateway endpoint just to show that at this stage, everything is connected and we're getting the expected result. So I'll go into my compiled directory. Okay, so next to show how the current state of the app works if we were deployed to the cloud, we're going to actually complete a PulumiUP, which will then persist this app in US East in AWS. Okay, now that this is completed, we have a URL that was given to us here. This is the URL that represents the API gateway and is a public URL. So I'm going to copy it. So what I'm going to do is I am going to come back to this tab where we ran our URLs, and I'm going to recall the same request we sent earlier. And all I'm going to do is I'm going to come to the local host and I'm going to replace it with the URL that was returned to us in the Pulumi output earlier. So I'll go ahead and just paste that verbatim. Sorry, a couple typos here and here. So now I'm running the recognize endpoint on our deployed app. And as we mentioned with the earlier modifications, you'll see that the result now says recognizing text rather than the actual result. So now we're going to do the same thing on the result. And sure enough, you see that our result actually has the process text inside of it. Once again, this is a separate Lambda that's pulling from DynamoDB to get those results. Now for our final update, we're going to do something that would normally be extremely challenging at this point in a app's lifecycle, but it's something that's actually quite easy to do with Klotho thanks to the investments we made in adaptive architectures. So what we want to do is we want to take these two API Lambdas and turn them into long-running processes. In this case, we want them to be pod running in Kubernetes or EKS more specifically. The reason for that is to avoid cold starts on these, etc. We still are going to leave our actual processing as a Lambda. So the way we accomplish this in Klotho is through config. When we ran our last compilation, we actually have an additional file in here, which we didn't take too close of a look at yet, called klotho.yaml, which I'm going to actually go ahead and pull out. And what this has is everything that Klotho currently configured for our app. So a lot of this is defaults based on the fact that it hasn't been specified yet. So what we're going to do is delete everything here that we don't want to modify. We're only going to keep the modified aspects. So in this case, what I'm going to leave is just this front matter up top and our execution units. I'm going to take out all of these extra parameters, including network placement, memory size, etc. And all we're going to do is modify both of these APIs to be, instead of Lambda, EKS. And if we run our exact same compilation as before, we're going to pass in our klotho.yaml as an extra argument, passed in with -sheet config. The best way to think about this is sort of like style sheets. We're going to override what's on top of the defaults. So those things we wrote into this klotho.yaml will override the defaults that Klotho generates. And the end result is that we are given a similar diagram, but as expected, the two Lambdas are now EKS pods. If we were to rerun the deploy here, this would do everything to spin up the EKS cluster, wire it such that the API gateway can communicate into this pod, as well as this pod, and everything should continue to work as expected on your next deploy.
Thanks, Aaron. To summarize, Klotho allows you to write plain application code, add annotations that are both contextual and declarative, and it'll transform that code into a cloud-native version of it, producing Pulumi infrastructure as code and a slightly modified version of your application that runs and leverages those constructs. It allows teams to have a generational leap in productivity when it comes to backend development, while still keeping all the benefits from Pulumi and the underlying layers, and making them pluggable into your existing infrastructure as code. Give Klotho a try at klo.dev, and thank you for your time.